Hello, this is Mr. McLeod, and this video is going to introduce you to simple uh, filters in BlueJ using ImageLab. So you should have already done activity 3, which was to download ImageLab, and it showed you how to compile and run it, and how to do some filters, in particular the filter that was already came with the program, and then it's kind of stepped you through that example filter, and it showed you the image provider API. This API is going to come in handy later when you're trying to do your own filters, especially when you want to do color filters and you're looking for, like, how do I get these different pieces of information from the image provider. Okay, and then you stepped through here and eventually you completed this double image BW. So what we're going to be doing today is the next assignment. So if you went back out here and you went to lab 3A B and W filter, we're going to look at how to make your own black and white filters. There are options given to you right here. So you're going to be making 3 black and white filters. You can either make up your own or you can choose from the options below. Whatever you decide to do, though, you need to write a comment at the top of your code explaining what your filter is supposed to do, right? So if you did the vertical flip, it would be enough to just say that it's a vertical flip, right? If you did rotate 90, say what it is. If it's a custom filter, you're gonna have to describe, exactly what the idea behind the filter is. Okay, so there's some plenty of options here, going kind of in order of, sort of in order of difficulty, not fully. There's like a list of, okay, so basically there's a list of bronze ones. These are easy, relatively. And then if you get down to here, there's some silver ones. These ones get a little bit more difficult, kind of medium difficulty. And then at the bottom here, the gold filter are hard. Okay, so you decide what level you want to do, and of course you can do a mixture of them, and I would recommend probably starting with 3 from the bronze, but if you're having an easy time, you could certainly try to challenge yourself and do some more difficult ones. Okay, so let's go ahead and get started without further ado. Here's my ImageLab. I just double click on the package.bluej in the outer folder here. Oh, I do want to point out, because you're going to be doing filters with images, some nice images that are available are in this. This kind of comes with a folder. It has some black and white images right here. And then there's also some color ones. I would go ahead and use the black and white ones when you're doing black and white filters for now. But it works either way. The black and white filters aren't depending on the image to originally be black and white. Okay, so then, and then also, while we're at it here, there's this ImageLab folder. This is the package, the ImageLab package that contains like the main ImageLab program. And then there's the filters folder, which is the package that contains all of the classes that you are going to be writing. So these are all the filters, right? So when you're looking to turn your files in, this would be the place to come to find your files. And in particular, you're going to want to find the files that are Java files, right? So if you have turned on the extensions, you'll see the .java, but it's also possible that you might not have turned on the extensions. So if you go up like on Windows, if you go to View, I have the file name extensions checked. If I uncheck it, you'll see that it just says HFlipBW. It no longer says .java. However, you can see over here that it still says Java file. And so this is important because please do not turn in the .class file, because the .class file is just the byte code that's produced when you compile the Java file, right? The Java file is the one that actually has your code. So let me check this back again. So for example, if you were to open this in a text editor, you can see this is the actual human readable code that you edit, right? Whereas if you were to open the .class file in a text editor, you would just see a bunch of numbers and letters that this is byte code, right? So definitely not human readable code. Okay, and then I guess while we're at it, I'll just cover this one. If you open this in a text editor, you can see this is even less useful. This is simply some information that BlueJ saves about the relationship between different classes. Okay, so the one you want to turn in is the .java files for the 3 classes that you make. Please don't turn in HFlipBW.java because that is not one you made. That is one that just came with the program. Okay, so we're going to go back one level again, and I'm going to double click on the package.bluej to open the project. And here we are. If you haven't compiled ImageLab already, you can open this up and hit compile. But if you don't see slash lines on it, you probably have already compiled it. And then you can double click on filters to open the filters. And then what you're going to be doing is you can start with the HFlipBW as a starting point. So to do that, if you just right click on the HFlipBW, you can say duplicate, and that'll give you a chance to make a duplicate class that has all the same code, but different name, right? So in here, I'm going to call this negative.java because the first filter I'm going to show you here, or the one we're going to do in this video, is to simply do the negative of an image. And I'll explain what that is in just a second. So I'm going to hit OK, and you can see now it's created a negative class. If we were to go into the filters folder in the project, you would see now there is a negative.java, right? Because that corresponds to, that's where the human readable code for negative is. Okay, so then if we open this up in BlueJ, right now, the only thing it's changed is the class name and the file name, right? It's made a copy that's called negative.java and it named the class negative. So then over here, we need to change the logic. So if you read through this code, you can see the first thing it does is just get a 2D array of short values that represent the black and white image. Okay, so what that is shorts are like ints, except they are shorter, right? So they can't store as large in numbers, but they take up less memory. So you can imagine if you have thousands and thousands of pixels, if each one takes up less memory to represent, then that could be a good thing, would save a lot of memory, right? So to give you an idea of like what are the kinds of things that it saves in there. Oops, I didn't mean to do that. To give an idea of the kinds of things that it saves in there, this is what I meant to do. You can basically, if we just drew a picture of, let's say we just had a 3x3 image, it would be very small, 3 pixels by 3 pixels. In each of these pixels, for a black and white image, there's going to be some number that is between 0 and 255. So maybe there's like okay, so there could be like 25 here. Maybe there's like 0 in this pixel. And by the way, 0 means black, right? So 0 is black and 255 is white when we're talking about a black and white image. So basically everything is somewhere on a gray scale from 0 being black to 255 being white. So if I were to put 255 right here, then this pixel would be black. Sorry, this pixel, the 255 would be white, and the 0 next to it would be black. Okay, so this is the kind of data that's in here. Okay, and then what we're going to do is write a filter that changes, that creates another 2D array that has, different numbers in here, right? So ultimately, that's the idea of the filters. And there's kind of 2 kinds of filters. Some filters are designed to get information about what should go in a pixel from a different location, whereas other ones simply modify the existing value by some calculation, right? So the one we're going to look at today is just going to modify by a calculation. Okay, so I'm just going to fill in the rest of these real quick. Let's see. The best tool, but it works. Okay. All right, so the idea behind the filter that we're going to be doing is we're going to take each pixel, right, each row and column. So there's, these rows are like 0, sorry, these are the columns 0, 1, 2, right, this is the columns, and then these are the rows 0, 1, 2, and we're going to create a new 2D array. We're going to modify the numbers in the new 2D array so that each number is going to be the inverse of the original number, calculated by saying we're going to start with 255 minus whatever the number is. Okay, so for example, if it was 25, we would do 255 minus 25, so we would get 230, right? Okay, if it was 0, then 255 minus 0 would be 255, right? If it was 255, then 255 minus 255 would be 0. So then in this case, you can see where the inverse or negative is basically changes all the numbers that used to be, or all the pixels that used to be dark, right, into light pixels, and all the pixels that used to be light into dark, right? Because you can see the black became white and the white became black, and then the ones that were like 25, where it's like dark but not completely black, becomes light but not completely white, right? Okay, And I think that's enough to kind of give you the idea. I don't think I need to fill in all these. Okay, so then to do that, we need to get the height, right? So this is like number of rows, right? And then the width, right? Or number of columns. And then we create a new 2D array of shorts, right? So we say 2D array, new image is going to be a new 2D array of shorts, and it's going to be the same height and the same width. Okay, and then we loop through the original image. I mean, actually, you could decide. It's not really going to matter in this case because the images are the same size. But one of the things you have to decide, and we'll talk about this later, perhaps when we do a more complex filter, is that you have to decide whether you're going to loop through each pixel in the original or whether you're going to loop through each pixel in the new image and grab data from the original. Okay, so basically you're looping through every row and every column, and at each row column combination you're going to say the new image at that pixel, right? So like if this was the first iteration, this would be 0 0, so it'd be the 25 is going to equal, and then you're going to do some calculation here, right? So I'm going to get rid of this calculation because this one was that was when we wanted to flip it horizontally. But this time, what we want to do is we want to take the same original number, right? Like the 25, but we want 255 minus that, right? So that was what our plan was up here, right? We said we were going to take 255 minus n, where n is whatever's at the position currently, right? Okay. So then the thing is, if you do 255 minus some number here, right, then basically you're taking an int minus a short, okay? And it turns out if you do any kind of calculations on an int and a short, then the answer is going to be stored in an int. And it kind of makes sense because basically, since an int is involved, then potentially numbers that are too big to fit in a short might be involved. As a quick review, ints are 32 bits, which means the largest int is 2 to the 31 minus 1, which is approximately 2 billion, whereas shorts are only 16 bits. So then shorts can only hold numbers up to around 32,000. Okay, so you got 32,000 versus 2 billion, right? You can see that there's going to be plenty of numbers that an int could store that a short could not. However, in both cases, since we're only storing numbers from 0 to 255, we can be very sure that every possible number from 0 to 255 is easily going to be able to be stored in a short. Okay, so what we're going to do here, though, is we need to satisfy the compiler, because the compiler is worried, hey, we might be losing data because the answer is an int, but you're trying to store it inside an array of shorts, right? So if we have a 2D array of shorts, then ultimately each of the items at each row column is a short, right? So what we can do is we can do typecasting to tell the compiler, go ahead and take this whole calculation, and you need to put the whole calculation in parentheses, okay? Because if you were to simply typecast one of the numbers, then the answer would still end up being an int, and so it wouldn't work, right? So you have to take the whole calculation, and at the very end, right, put parentheses in front of that and say this whole calculation is an int, right? So that it'll do this calculation in parentheses and then typecast the final answer to an int. Holy smokes, not an int, a short. It was already an int. Okay, so sorry about that. So we want this to be stored in a short. So we take the whole calculation and then we typecast it to the short, and that will solve the compiler's problem, right? Okay. So if we were to compile this, we could run it, but let's just go ahead. We're almost done looking through the whole code. So this is just taking each pixel. This is like the core of what we did, right? And we just did what we said our plan was here. Took each number, took 255 minus that number and stored it in the same position. So then what the rest of this is doing here is the way that the ImageLab works is you have to have an image provider in order to store an image. So we were passed an image provider that was like the original image. Okay, and then we're going to make a new image provider and set the black and white image for that image provider to the new image that we just made, right? Which is the 2D array, the new 2D array of shorts that we just filled with all the right datas. Okay. And okay. And then once you have that filtered image, you can call the show pics. And this is what actually like displays the image, like brings it up in a window. And this will be the title of the window. So we actually want this title to say negative, because we'll say like negative image. Okay. And then the other thing that we need to do here is that there's this get menu label. This is going to tell you, this is going to determine what shows up in the menu. So you need to change this because you don't want all of your filters to just say horizontal flip BW, or you won't know which one's which, right? So here you have to say negative BW, and then you'll be able to tell which one it is, right? So if we hit compile now, and then we go back to, see, probably the easiest way is just go up, open up ImageLab. Okay, and then right click on the ImageLab and say void main, press enter. So we're running the program, and I'm going to clear this now. Okay, so then this pops up and we can open an image and we can do a filter, and you can see there the negative BW is showing up as an option, right? But first we need to open the image. So we're going to say open image. Okay, and then like, let's say we picked our Lexi cat. And here's the original. And if we go to filter negative BW, there's our negative. Looks pretty cool. It's wild. Like, so all the black is, or all the white is now black. Okay, and then the cat has a lot of dark in it. So now the cat is like all light. It's pretty cool. Right, except for the paws, right? There's like some areas here where the paws were like white, the front little spot was white. So, all right, there you go. Now you know everything you need to know to do a simple filter, and you learned a very important thing, how to typecast, right? So remember, that was actually one of the critical things, because you're going to run into that anytime you do any kind of filter that involves taking a number, you know, and doing some kind of calculation and then trying to store that calculation back into your array of shorts. You always have to take the whole calculation, put it in parentheses like this, and then in front of that, in parentheses, you say short. So you're typecasting it to a short, which means you're telling the compiler do whatever you need to do to store this in a short, and it's okay if I lose data, right? And hopefully your calculation is set up so that you don't actually lose data, but there you go. That's how you can get the compiler to stop complaining. All right, so that's the end of this video, and happy coding. Enjoy doing your filters.